as an organizer and may now speak to any other organizers or panelists on the line. When you are ready to begin the presentation, press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hello, hello, hello. Welcome to Claigan's webinar, RoHS in 2019, Regulatory Changes in China RoHS and EU RoHS. My name is Bruce Calder. I'm the VP of Consulting Services here at Claigan. Pretty full agenda. It's actually kind of schizophrenic. There's two pieces to it. We're going to do China RoHS up front, the new first batch catalog of products with restrictions. And then we're going to do the new EU RoHS changes, the addition of phthalates for 2019, a lot of the more practical elements and also why the restrictions appeared. And then we're going to have a little summary and Q&A. So hopefully, it's a lot of material, so it might be slightly longer than 50 minutes, but hopefully within 50 minutes, we'll complete the presentation and then we'll have a little Q&A. If you have any questions during or at the end of the presentation, feel free to submit them in the chat window down at the bottom. So Claigan, we do quite a few things. Obviously do a lot of consulting. What are your products? Where do you sell? What do you have to comply to? And what's the best way to do it? We also do a tremendous amount of laboratory testing. We have arguably the largest or highest volume restricted materials testing lab, especially for finished products in North America. We do a lot on EU RoHS, China RoHS, Prop 65, REACH SVHC, REACH restrictions. Definitely in the Prop 65. We're probably one of the most dominant labs in that space. A lot in the EU, persistent organic pollutants, which many of you may not hear about or have heard about. It is your most likely source of recall for restricted materials in North America or Europe, primarily around a chemical short-chain chlorinated paraffins. It has roughly 20 times more recalls in RoHS, if not more, in the EU. So very, very important one. Also gets you a lot of trouble, especially in Canada. It is a banned material. It is extremely common. You want to make sure you take care of that. We do a lot of WE implementations. WE is fairly non-harmonized, which makes it a bit challenging. So what we do is we try to centralize the entire registration, reporting, recycling through one channel to make it a lot easier. And just a simple matter of filling out Excel sheets and paying little invoices each month. We also do a lot in the medical space, the EU device regulation, new restricted materials, the CMR restrictions, the allergen labeling requirements. We also do a lot in the Healthy Hospitals Initiative, which people in the medical space probably have seen a lot more demand from their customers, especially around things like phthalates, etc., and we're here to help. So we work on these and a tremendous number of other global restricted materials requirements, also a lot of custom requirements related to specific customers. We can usually help you through, or if you have a request they don't really understand from a customer, we can probably help explain what you're supposed to be doing. One of the big things that makes this difference is our focus. We focus on compliance. Your product needs to be compliant. You're not doing this for fun. You're doing this because you want to sell in a region, a particular type of product, and it has to be compliant with the requirements of that region. We also focus on end deliverables. So that's a big part of our focus. What are the outputs? Data gathering is not an output for RoHS. The output is a product that meets materials restrictions, a technical filing showing you a conformity assessment, a declaration of conformity, and the CE mark. So we focus on what's the outputs and what's the best way for you, the way you do business, the way your products are designed, the way your products are manufactured, to create those deliverables. And if a step or a process doesn't help create those deliverables, we cut it out. We look at REACH SVHC. It's a disclosure requirement, not a restriction. What's the best way to create that disclosure? What's the most effective manner to create disclosure? The most important thing for REACH SVHC is not gathering data. It's, can you provide that declaration? If you cannot, you are not allowed to sell in the EU. If your declaration is potentially incorrect, then you're looking at some warnings, probably some updates. The most important thing is not the data collection, it's the ability to provide that declaration. So focusing very much on the compliance side and the end deliverables. What's the best way to create the deliverables you need? So off the bat, We're going to talk a little bit about the new China RoHS, the new catalog. It's not actually a change in China RoHS. It's the first of the catalogs of restricted products, or products with materials restrictions. So we've talked about a lot before. The original China RoHS and the new China RoHS are kind of broken into a bunch of groups. There's always been a labeling requirement. If you have a restricted material, one of the EU RoHS materials above 1,000 ppm, or 100 ppm for cadmium, of course, you need to provide a label on the product with its environmental friendly use period, which in oversimplification, that number is the number of years. It's your shelf life of your product plus the operational life of your product. For short-lived products, it's generally the shelf life, so single-use electronics. For long-term products, or it's long-lived products, it's the operational life. You'll also need a hazardous materials table by assembly, which marks which assemblies have which substance over a declarable limit. So for example, if you using the lead in copper alloy exemption for EU RoHS, which is quite allowed, you still have to mark lead in that assembly, or using thick film resistors, which use the lead and glass and ceramics exemption. You just have to mark it, but you need the table. The requirement's a table and a label. There used to be a mandatory package recycling marking requirement. Now it's only recommended. It's basically marking the packaging of the product with a variety of symbols for plastics, 1, 2, 3, 4, 5, 6, 7, and cardboard paper with the more common trailing arrows symbol for recyclability. Now it's voluntary, it's not mandatory. And then there's always been substance restrictions under China RoHS, but those restrictions only apply to products listed in subcatalogs. So their laws always had restrictions. But until there were products in a catalog, then the restrictions didn't actually apply to anything. So what we're talking about here is the first catalog, the first batch of products under material restrictions have been released. So what we're going to talk about is the product families that now have, or will have soon, more accurately, materials restrictions, EU RoHS-like materials restrictions. So the laws always had materials restrictions, but it only applied to products that are listed in subcatalogs. And up until now, there's been no catalogs. The first batch of products, the first catalog, has been released. So it was released in March 2018, and it goes into effect 1 year after release, March 15, 2019. Oh, by the way, everything here is public information, but it's all in Chinese. So some things we talk about here might be off subtly. There's always a chance for paraphrasing. And we'll definitely, when we get into the product category segment, there's a lot of opportunity for misinterpretation. But basically, the catalog actually isn't a single document. It is 2 documents. The one is the list of products, or product families more like it, that have EU RoHS-like restrictions, have restrictions at 1,000 ppm for lead, mercury, hexachrome, and the 2 brominated flame retardants, and of course 100 ppm for cadmium. It also has a second document, which is which exemptions are applicable. So these are the products under scope, and these are the exemptions. People have already talked about China RoHS has no exemptions. Well, no, it has no restrictions. And if you're using an RoHS exemption, so you're over an RoHS limit, you just had to report it in a table. It wasn't restricted. You just had to report it. Once, hopefully my audio just didn't just kick out. Well, hopefully my audio is still there. My thing's giving me a bad look on audio. So hopefully I'm still there audio-wise, and I apologize if I drop out. It's usually pretty good. So if I did drop out, we'll get back there in a second. So one of the key things, there we go. Hopefully my audio didn't just drop on everybody, but where we are back. Our China RoHS has always been labeled as having no exemptions. Well, it didn't have exemptions because it didn't have restrictions. When the exemptions appeared, when the restrictions appeared, then the exemptions appear. So the catalog itself, the first batch, is actually 2 documents. It's not a single document, it's 2. One is the materials restrictions, which products are under the restrictions. It's a list of products or product families, which we'll describe in a second. And the second document is which exemptions are applicable. So there's 2 documents in this first catalog. So there are really 12 products families under scope. Now, what we've listed here is the generalized names for them. In reality, actually, there's a little more to them. Each one has a variety of details that further limit it, mostly in size and scope. For example, one we did put here, our washing machines are limited to washing machines of 10 kilogram dry load of clothes or lower. So ones that have a capacity of 10 kilograms of dry clothes or less. So there are size limitations. The ones in scope are somewhat limited, and every single one of these have different. So whether it's refrigerator, air conditioners, washing machines, water heaters, printers, copiers, fax machines, which I didn't know still existed, TVs and monitors, which are becoming more blended these days, computers, including desktop, laptop, PDAs, and tablets. Tablets and PDAs are all kind of blending, and cell phones, which are kind of blending with the other ones, and home phones. Now, each one of these actually has more details under it. So if you believe your product might be one of these, you probably want to look at more of the subtle details. Now, each one's in simple Chinese, and we're not going to go into it here. There's a lot of subtleties around each one. They're mostly aiming for mainstream consumer type products. And so usually the size limitations, like the printer, it's like a 48-inch printer head or space. There are limitations. Printers with a head larger than that are not in scope. So big industrial printers are not in scope of this. So you have to, if you worry about, hey, I have to make a printer, a copier, but it's more of industrial, there are more detail in the catalog, in the first batch, the first document, on what's actually in scope. And each one of these has a little more detail of what they mean by computers or TVs or monitors. But it's basically, in overgeneralization, there's 12 product families in scope. There's a second document with exemptions, and these exemptions are virtually identical to the EU RoHS Annex 3 exemptions, except the numbers are different. In general, the numbers are one higher, for whatever reason, and the ABCs are also numbers. So 6C is 7.3 in China RoHS. That's one higher. Instead of being 6, it's 7. Instead of being C, it's 0.3. They also have values. So a lead in copper has a max value, which I can't remember, 3.5% or 4%. My memory fails me in the old days. Listed next to it. And there are a number of exemptions, like 7C1, which is 8.3.1. So 7 is up 1, 8. C is a 3, and the 1 is a 1. So 7C1 is 8.31, which is ceramics, lead in ceramics and glass. One's been used in thick film resistors and diodes forever. It has no limit. EU RoHS, there is no 5%, 10%. It's infinite. And what they actually do in China RoHS, they list specifically it is an infinite value. There is no limit. So it's really actually a table of exemptions and the limit. So there's a very slight differences, the biggest one being naming conventions. Otherwise, they're virtually identical. There's also no explicit renewal dates or cycles. So unlike EU RoHS, which many of the important lead exemptions have been going through a renewal process since, and they should have been complete in 2016. It's still ongoing. Most of them have been published in draft form, the new EU ones. And unfortunately, because it's 2018, they have to go through your have your say consultation with the outside world. So they're going to be another 3 months at least as they go through this additional, now mandatory public consultation before they're released. And what you're going to see in the EU side is the exemptions are more or less, the lead ones are going to stay pretty well the same, but they're going to sometimes change names or be split for future restriction. They're also basically being extended till 2021, which means they're going to enter a renewal process probably in early 2020. When that occurs, if they change, or even the splitting is going to happen in a couple months. It's not clear what's going to happen on the China RoHS side. What we believe is eventually they'll update the exemptions on the China RoHS side, but there'll be some sort of delay. So there's very likely the China RoHS exemptions and the EU ones are going to be out of sync, with the China RoHS ones probably just being a little bit later in getting put through. So basically anything that's acceptable under the EU should be acceptable under China. Whenever an exemption sunsets for the EU, there might be more time before it sunsets for China. But it's oversimplification. Basically, EU exemptions will be applicable here. Again, if you have any questions during this, feel free to put it in the chat window and I'll get to as many as I can at the end. The conformity assessment, there's still no specific conformity assessment method. You don't have to get it tested in a Chinese lab, etc. We expect the conformity method will be somewhat similar to other international methods like EN 50581. There'll be a number of different standard ways to do conformity assessment through risk mitigation and identification of information required and collection of that information. So it'll be probably similar to the European one. We don't really expect any significant difference. Test report being perfectly valid, but it won't necessarily have to be from a Chinese laboratory, just one following international standards. Now the table and label requirement are unchanged. So basically, if you have a restricted material above 1,000 ppm or 100 ppm for cadmium, And even if it's an EU RoHS exemption, which is one of the most common, you have to identify with an X in a hazardous materials table to a particular format. And this is irrespective of the product, whether it's in this first catalog or not. So basically, if electronic product, finished products coming into China, it still requires a table and label. If it's in the first batch of products with restrictions, it needs a table and label. If it's not in the first batch, it still needs a table and label. It's unchanged. The table and label requirement is still unchanged. Now, for some reason, it's our EU RoHS compliant and it uses no exemptions, then the actual table is not required. It's only in the case where there are no substances above the limit that table is not required. So you can actually be compliant with the restricted materials requirements and still need a table because you're using a lead and brass or a lead and thick film resistor, lead and glass, basically a thick film resistor or diode, and it has an exemption and you're above the limit. So whether your product's under materials restrictions or not under materials restrictions, the table and label requirements still apply. They're unchanged. So a little summary in the new, it's not the new China RoHS, it's the first catalog or first batch of products under materials restriction. The law itself is unchanged. It basically has specified for a long time that there are materials restrictions in China RoHS. They just only apply to products that are in subcatalogs. These catalogs had not been published until March of this year. So now there are restrictions to 11, 12 categories of products. They're fairly specific. As broad as they are, they do have limitations, such as a dishwasher are only in scope if they have less a volume, a dry close volume of 10 kilograms or less. And most of the different categories have variety of restrictions. It isn't a refrigerator of unlimited size. You're not necessarily looking at professional restaurant, large scale refrigerators. They do have size limitations. And it includes the EU RoHS exemptions, at least the Annex 3 exemptions, the standard ones, but the numbering has changed. So that 6C is now 7.3. So there's some numbering change just to make your life difficult. And the table and labels requirements unchanged, and it goes into effect for non-medical, non-monitoring control March 15th, 2019. Actually, about to say EU. Monitoring control is the next chapter. It goes into effect, but for the affected products, March 15, 2019. So these 12 specific categories, not 11. The restrictions go into place March 15th, 2019. The medical side and control monitor and talk more in the phthalate section in a moment in the EU side. But China RoHS, the restrictions only apply to those specific categories in this first batch, and they go into effect March 15th of 2019. Most of which will probably already meet the compliance requirements. If they have a local model, like sometimes refrigerators, because of the compressor made for a specific market, they for some reason may not be compliant with the materials restrictions and may need a redesign. But on average, most of those product categories are generally compliant to the restrictions that are here. Conformity assessment, there's no specific process at this time. Now, on to the EU side. So EU RoHS in 2019. In 2015, not 2019, in 2015, the restrictions in Article 4 of RoHS were updated. So since 2002, it's only been 6 substances: lead, mercury, cadmium, hex, chrome, and the 2 brominated flame retardant families. Now it's been updated in Delegated Directive 2015-863. When RoHS Recast was created, inside of it, there's a delegated powers to the EU Commission. So the EU government is really made up of 3 levels. One is the Parliament, which is elected directly by the people, and it's the one that usually gets the laws going. The EU Commission, that is appointed by the elected governments of each country, which generally try to rein the Parliament in. And the EU Council, which is appointed or divvied up by the different member states. Inside RoHS Recast, the law itself delegated to the Commission, so the elected governments of the different countries, the ability to create certain laws without going back to the Parliament. And they're called Delegated Directive, and they're all technical in nature. They're either exemptions, or in this case, adding new substances to the restrictions. And they did do that. In 2015, they added 4 low molecular weight orthophthalates. Now, when we talk about phthalates, it's not all phthalates. We're almost always talking about orthophthalates. In this case, we're talking about the low molecular weight orthophthalates. There are also terephthalates, which also are plasticizers, but they generally do not have the same negative properties. These are orthophthalates. And these are the low molecular weight ones, the ones that generally metabolize in your system into more harmful form. And these ones, DHP, BBP, DBP, and DIBP, are restricted to 1,000 ppm in homogeneous materials. So very similar to the other RoHS restrictions. It's just a new family. It's 4 new substances, all low molecular weight orthophthalates. Now, when is the deadline? It's required for products placed on the market after July 22nd, 2019 for most standard products, and July 22nd, 2021 for medical IVD and monitoring and control. So, but the funny part about it is categories 1 through 7 and 10 are in scope of 2019. Somehow category 11, which only comes in scope in RoHS in general, in July 22nd, 2019, actually comes in scope with the phthalates right away. So they kind of go right to the end. They could probably apply for an exemption if they wanted to. It's probably too late now to postpone it a little bit. But in absence of that, categories 1 through 7, 10, and the other category 11 all have to meet the phthalate restriction, July 22nd, 2019. Place on the market simplified is not the date of manufacture. Oversimplification, it's the date of custom clearance from importation into the EU. It's when a specific unit clears customs after importation in the EU. That's the key date. Now, if it's made in the EU, it's a little more complicated. It's when it actually transfers ownership from the entity of manufacture to the entity of distribution. And usually that's by transferring the ownership to a different entity, which can often be the same ultimate company, but transferring from one entity to another is the date of that transfer. When it's transferred from the stage of manufacturing to the stage of distribution is the place to market, if it's manufactured in the EU. If it's imported, it's the date of custom clearance for importation with a variety of other little rules. It has to be available for sale. So for some reason, it's not available, you couldn't buy it, or it hadn't passed EMC compliance yet, and it would not be available for sale, it's not placed in the market. It has to be finished and ready for the end user. If it meets all those criteria, then it's placed in the market. But if it needs another manufacturing step after importation, not a kitting, but a manufacturing step, it's not placed in the market. But the vast majority of times, if it's imported product, it's the date of custom clearance from importation. That is the place in the market date. Even though you might have been selling this design type for years, any unit placed in the market after July 22nd, 2019, of course, excluding medical, IVD, and monitoring control, has to meet the new materials restrictions. And the key date is the custom clearance. So for some reason, you bring in 100 units in July 20th, 2019, and it clears customs on the 20th, 2019. Even if they're not sold to the end user, as long as they're available for sale and completed, no more manufacturing required, they're placed in the market and do not have to meet the new materials restrictions under RoHS, even if not sold to the end user for years. So the key date for place to market for an imported product is the date of custom clearance. The key date for when manufactured in Europe is actually the transfer of ownership from the stage, the manufacturer to the distributor. The distributor can be an owned company, can be the same overall company. It just needs to have ownership or the right of ownership transferred. It's a bit of a complicated topic, but you want to show the date where it's transferred from the stage of manufacturing to the stage of distribution if manufactured inside Europe. Question is, why were the phthalates added? First of all, RoHS is not related to consumer safety. It is related to the safety of recycling workers. The reason actually RoHS was created is sort of a side thing. What ended up happening is the WE Directive, the Waste Electrical Electronic Equipment Directive, was created many years ago, and it's around transferring the responsibility, i.e. cost, of the end-of-life electronics from the users and governments to the importers and manufacturers. In so doing, they realized they were horribly poisoning the recycling workers, and they couldn't implement this cost transfer / tax while endangering recycling workers. So they had to put materials restrictions in place to protect recycling workers. And because of that, when they look at adding new substances, they have to see whether or not it's actually a danger to the recycling worker. It's not related whether it's a danger to the consumer or general worker, it's whether it's a danger to the recycling worker or their environments. Very recently, the low molecular weight phthalates were classified as category 1B, known to cause in animals reproductive toxins. The way they actually are is they reduce the sperm count of adult males, amongst many other things. But the main one they get approved under is the reduced sperm count. So that's a reproductive toxin. And the EU did testing, and they found that these phthalates were appearing in the bloodstream of recycling workers, in the air and dust in facilities, and in the environment surrounding the facilities. And because these are category 1B reproductive toxins, they pose a hazard to recycling workers, and therefore that's how they got approved for restriction. So to go through this, a substance basically has to be put forward and be shown to be a danger to the recycling worker or its environment. Now, what's wrong with these substances? So they're categorized as category 1B reproductive toxin. The big problem with them, they're endocrine disruptors. And they aren't theoretically endocrine disruptors. They're, from a regulatory point of view, now endocrine disruptors. And what that means is you can call anything you want to, but it's not officially an endocrine disruptor until it's gone through an official classification process. And for endocrine disruptors, they have to go through the REACH SVHC process and be identified as an endocrine disruptor at the end of the consultation. They theoretically can go through the biocides process, but for a variety of practical reasons, that doesn't happen. So almost all substances that are classified as endocrine disruptors are REACH SVHCs, because the only way they're going to get classified is through that process. And if they don't go through that process, no matter how negative their capabilities may be, they're not endocrine disruptors from a regulatory point of view. They have to go through a classification process, which today means the REACH SVHC process. And what's wrong with phthalates is their metabolites are estrogenic endocrine disruptors. Estrogenic means make more female. Estrogenic or have female-causing factors. They're estrogenic endocrine disruptors. And the funny thing is DHP itself is not really dangerous. It's its metabolites. So DHP is diethylhexyl phthalate. MEHP is monoethyl hexyl phthalate. When it's ingested, sometime either through the intestine or I believe the liver actually, it gets metabolized. And one of the ester arms, one of those big, looks like waving arms, like hello, one of those waving arms, the DHP, leaves, gets metabolized and leaves. Bye-bye. And it has a new property. This MEHP, and I'll show you why in a little bit, has estrogenic capability, as does a number of the other metabolites. One of the reasons why some of the high molecular weight phthalates do not have these properties is when they metabolize, they actually don't quite metabolize into the same thing. They actually generally metabolize in slightly less harmful forms. And it's probably why DANP and DIDP are not seen to be as harmful as DHP and the other low molecular weight phthalates. So it's actually the metabolites that are the problem children. So what is an endocrine disruptor? An endocrine disruptor are, again, the only way they get classified today in an official form, they can be as bad as one thing. So they could be a potential endocrine disruptor like octosalicate, which is one of the main ingredients in most sunscreens. But until it's classified as an endocrine disruptor, it's not from a regulatory point of view. It has to go through the SVHC process. And one of the main parts of this is these substances, they mimic estrogen. And what it works out is estrogen has a particular chemical structure, and I'll show that in a moment, which is basically the key to the estrogen receptor lock. So in your body, you have estrogen receptors that are basically locks looking for this key. And if they have the right key and locks the estrogen receptor, it makes your body respond as more female. So if a substance has that structural element or a chemical element, it can trigger a female response in the body. And basically all the ones we're going to talk about are estrogenic, and they have a similar structure, or at least trigger the endocrine disruptor, the estrogen receptors in the human body. So basically they have similar enough keys that they can trip the same locks in the body to make it respond to be more female. And so they can disrupt the endocrine system. Virtually every single REACH SVHC endocrine disruptor today is estrogenic. Basically, estrogenic makes animals or fish more female. There's also androgenic. None of them are SVHCs. There's some weakly androgenic or potentially androgenic. Of course, they've never gone through a classification. Things like spinach or quinoa are slightly androgenic, make animals or fish slightly more male. But the only ones we're going to deal with are estrogenic. So I'm going to talk about Bisphenol-A, because it's one of the best known. And what the estrogenic endocrine disruptors do for males, for young males, they create anxiety, not depression, more an inability to sit still, often called attention deficit. For older males, they reduce fertility, basically reduce sperm count, which is not surprising. You make a male slightly more female. It's not surprising the sperm count goes down. Female outcomes are quite different. You make a female more female, it's quite different. It's usually precocious puberty, early onset puberty. And what we see in rats, really what it's done is it creates a hyper-accelerated growth of a lot of female organs, including ovaries, and to the point where Lewis rats often have ovaries 1.5 or 2 times normal size. And that hypergrowth also, like a lot of other hypergrowths in the human body, can result in cysts. In this case, we're looking at ovarian cysts. So very different outcomes for male and female, and potentially why attention deficit is a fairly male-dominated problem, not exclusively, but fairly. And what it really is, if you look on the right side, there's estradiol. And estradiol is the main estrogen. And the left side of it's the key element. That's the key for the estrogen receptors lock. And it's that benzene with the OH. It's basically a phenol group, also called the trunk benzene. It's got an alcohol group on a benzene. That's the left side. And if you look at bisphenol-A, above it, it's got the same structural element. And it's not as potent or as effective. The rest of the chemical structure does have an impact on it. But it does have fairly estrogenic capabilities. And if you look down below, MEHB doesn't quite have the same structure. It's very similar. There's a double bonded oxygen and carbon in there to make things a little bit different. And it has about at least 100 or 1,000 times less potency than estradiol, but it does trigger the same effects. So not as well, and it's structured a little bit different, but it also triggers a lot of the estrogen responses. And this is similar to most of them. So nonylphenol ethoxylate is the same thing. Nonylphenol ethoxylate, until 2005, is the main laundry detergent. And the nonylphenol ethoxylate itself is relatively harmless, but if it metabolizes in the environment, it loses the ethoxylated part, and it ends up with another one of these phenol sections, creating the same problems. So a lot of them have a very similar structural element that triggers the estrogen receptor and makes animals or fish more female. And the male outcomes and female outcomes from all the papers look to be a little bit different. One of the things you also see, if you're looking at a lot of future regulation, the European Chemical Agency came up on their website a couple weeks ago saying the endocrine disruptors are strongly estrogenic ones, which is everything we're talking about, are strongly linked to autism. And they haven't 100% figured out the mechanism yet. It looks more like they disrupt the hormones, the thyroid hormone function in a pregnant mother during the perinatal phase, and that affects brain development in the child. It has more effect, of course, because it's sex selective on males, and that could explain why autism is a fairly male-dominated issue also. Now, science is still in progress, but from a regulatory point of view, an important part about this, if the European Chemical Agency is confident enough to put it up on their website, we're looking at more regulation. If they're confident enough to say, hey, you know what, there's a strong link from these chemicals and autism, I expect more regulation to come along. For example, I would not be shocked if Bisphenol-A is the next RoHS substance the next 5 years. It would not be surprising. When people go, oh my goodness, that's going to affect my polycarbonate. Polycarbonate has only trace Bisphenol-A. The average polycarbonate has about 10 ppm or less BPA. It's fully reacted. It's a non-issue. Where you get BPA is flexible PVC. Flexible PVC often gets hot melted in an oxygen environment and will oxidize and basically not work properly in that situation. So they will often use BPA as an antioxidant in the dye, so it'll be around under 10 ppm, or sometimes they use it as the antioxidant in the PVC, so you see it in the 100 or 200 ppm range. But they very commonly use it as the antioxidant in the plasticizer with the phthalates. And then you'll start seeing it in the 1500, 2000 ppm range, much higher levels. So the higher concentration BPAs that we normally measure are in as the antioxidant in the plasticizer in flexible PVC. So this substance is actually relatively common, not to go on a diversion. The main regulatory thing to take away from this, do expect a lot of these endocrine disruptors, if they can prove the recycling workers to show it in their bloodstream, are going to be restricted. BPA being probably the most likely substance to be an RoHS restricted substance in the next 5 years. Now, where are phthalates used? We're talking about the restriction of phthalates to get back on track, on message here. You take rigid plastics like PVC. PVC's natural state is like your piping or eaves troughing, or often called gutters. It's rigid. It doesn't bend. To bend, it needs a plasticizer, and what the phthalates do is they get between the vinyl chloride strands. So PVC is polyvinyl chloride. It's made up of vinyl chloride strands, and it gets between the vinyl chloride strands and pushes them farther apart. And by pushing the vinyl chloride strands farther apart, their bonds of attractions get weaker. This is similar to when you take two magnets and you bring them close together. They pull much harder on each other. When you bring them farther apart, the attraction is weaker. And it's the same thing with the vinyl chloride. If the phthalates get between the plasticizer, it pushes the vinyl chloride strands farther apart. It weakens their bonds of attraction and creates more fluidity. So the strands can move independent of each other, which you see as flexibility or softness. So the plasticizers, what they do is getting in between the vinyl chloride strand, pushing farther apart, weakening the bonds of attraction, creating flexibility or fluidity. So these phthalates are very heavily involved in creating flexibility, softness in materials. The main high-risk materials are flexible PVC, for the reason we just talked about, neoprene, nitrile rubber, styrene butadiene rubber. A number of adhesives, for some reason, use it in the formulation, and toughened or rubberized ABS. ABS is normally quite rigid. If you make an ABS that's, protect a computer laptop when you drop and it's slightly softened, they can use phthalates to soften ABS. It's a rare situation. Now, when it is used, it's extremely high concentrations, 1,000 to 300,000 ppm. You take a 220 volt power cord, the outer PVC jacket is often up in the 200 to 300,000 ppm DHP ranges, or DINP nowadays. Huge concentrations, extremely high concentrations. It's usually a very, very high concentrations. Now, sometimes you can get DHP in the 1,000 or 2,000 ppm range when it's used as a co-plasticizer with DINP. So even DINP at times, you'll get high concentrations of DHP. You'll also see low concentrations of DHP for some non-phthalated plasticizers like Totem. Totem is made from mellitic anhydride. Mellitic anhydride has phthalic anhydride as a contaminant. When you esterize mellitic anhydride to get Totem, you also esterize the phthalic anhydride and you get DHP. So Totem plasticizer material will often have 100 ppm DHP. Below regulated levels, but there, low concentrations. Not abnormal. Most of the time when phthalates used, or orthophthalates use the plasticizer, it's a big, huge number. Now, one of the reasons they use DHP over the non-regulated, well, outside of California, DINP, or outside of toys, is one, it's cheaper, slightly. The other is you only need about 80% or 75% or even less DHP that you do to DINP. So whenever you have to create the same durometer, same softness of material, you have to use more DINP, and the material properties do change a little bit. So DHP is generally easier to make softer materials, making it more difficult to use DINP, but DINP is quite commonly used, and so are a lot of the other ones. The terephthalates are used quite commonly now, adipates, and there are many other options. Now, what types of components are high risk? Wires and cable, obviously. The PVC jacketed, soft, but also strain relief. When we look at DHP problems, it's very commonly strain relief at the end of the connector. If we look at the power cable and look at the outer jacket, the end connector is also flexible PVC, and the strain relief is often quite phthalated. O-rings and gaskets, of course, PVC O-rings and gaskets. Sealed radial bearings. Sealed radial bearings use a nitrile rubber seal for the most part inside, which is often phthalated. Not shielded ones would use a metal. The sealed ones would use nitrile rubber inside. Motor belts are often a neoprene PVC blend, both of which are often phthalated. PVC stickers, of course, which we see relatively often. So a variety of soft rubber components. Synthetic leather is normally vinyl. And of course, vinyl covers, where we're looking for really exciting phthalates and such. We look at vinyl cover. Somebody makes a nice piece of test equipment, and then it's got this vinyl cover on it. It's phthalated to the nth degree. So these are a lot of the higher risk ones. Again, we're looking at all these soft things. Plasticizers that make things soft. Now, there's a lot of compliance challenges. First of all, the data is not readily available. As opposed to RoHS 2, the original RoHS, which has been kicking around since 2002, the data for that is readily available on everybody's website, distributor websites, etc. This one's not. It's also not very reliable at all. We're seeing that a lot. People think, hey, at the point where we have no ReachS VHCs. Well, you have ReachS VHCs, they end up in the phthalates, which is also one of these. They're also sometimes SCCPs, which is a stop ship issue because of persistent organic pollutant regulation. We're finding the reliability of this data is poor at best, and that's being optimistic. One of the other problems, the ask is not clear. Used to be asked, is it RoHS compliant? And they say yes or no. Well, what do you ask now? Is it RoHS 3, RoHS 10? RoHS with phthalates. The real name is really RoHS compliant, including Directive 2015-863 on phthalates. It just rolls off the tongue there. And anything with semantics, especially when you move to a non-English language, you go to Asia, will cause problems. It's RoHS compliant. Well, it's not the same anymore. So having the ask being complicated or non-standardized, industry hasn't said, hey, we're going to call this RoHS 10 or whichever, is creating problems. It's also not a data gathering project. It is often a redesigned product. Almost every complex electronic device, even though they don't think so, they usually have phthalates. Whatever you think your ReachS VHCs are, you'd be surprised you're probably not correct. You'd be amazed where the phthalates get into it. Also, we talked about the parts that use phthalates. Those are often lower cost parts. And one of the greatest enemies of restricted materials, or quality in general, is per part purchasing price, where you have a mandate to reduce the part cost. And these parts are often the ones you get from the cheap supplier. Oh, I'm just going to throw a USB cable in there, or a grommet, or I'm going to have little rubber feet on the bottom, or I found a cheaper wire harness supplier. Yep, And one of the reasons they can be cheaper is controls. And it's a quality issue. And so we see phthalates all the time. You take a cable harness, it's really complicated because it's not often one spool of wire. Each one of the colors is a different spool of wire. And the possibility of error becomes quite high. Also, we're finding the controls are not in place to maintain compliance. Too many companies are doing what we call data gathering after the fact, after design. And the specifications haven't been put in there and they're not maintained through change orders, etc. This is really a specification. This is not an after the fact data gathering project. This is a specification requirement, like length or height or anything else you specify. So these create a lot of challenges. Everybody's like, well, we've done RoHS 2 before. I mean, this one's going to be easier. Nah, it's actually harder, significantly. So what do you have to do conformity assessment? Do I have to regather the data for all my parts? Well, no. First of all, conformity assessment is the EN 50581, which is pretty wide open. However, the main tenets of it is the manufacturer is required to determine what information is needed. Well, that's great English there. But anyways, it needs to determine what information is needed, collect that information, evaluate the validity of that information, keep the information up to date, and manage the risk of the data being incorrect, which it often is. So that's the requirement. So the manufacturer, you're required to determine what information is required. For example, can phthalates be in metals? No, phthalates cannot be in metals. So you can identify that I do not need new declarations for metal parts. An RoHS 2 declaration is sufficient. You can identify that I don't need single part data. There's no requirement in the standard to say I need data for every part or at a part level. You need to encompass it all. So a supplier level declaration can encompass all the parts provided by the supplier. Also, a test report for the product meets the conformity assessment. It's one of the documentation types listed in there. If a test report for the product, that meets the conformity assessment requirement. It's actually easier. It's actually much easier to supply to a national authority. In basically every single case where the national authority has identified a non-compliant product for RoHS that we've been involved with, the first thing they ask for is the test report. They don't say tech file, they say test report. And if you have it, it's actually difficult for them to enforce. They really have to come to a negotiated solution because you've done the conformity assessment. It's very clear. Now, you can provide a technical file, but you have to provide it. Providing them a list of gathered data is not helpful. You have to be able to provide them a tech file or a test report. Test report is what they're going to be asking for. So it's important from a practical point of view. This conformity assessment you are doing for the CE mark, the main purpose is you have to be able to provide it to somebody. Can you? And that's an important thing to think about. Is data gathering successful in making an RoHS compliant product? Not most days. Generally, no. For example, we test a lot of product here, quite a few a day for RoHS, probably 5 to 10 a day at least. In 2017, 60% of the finished electronic products use data gather alone as their compliance method failed RoHS 2. This is 11 years after RoHS went into effect. It's still failing all the time, if not more. The data gathering isn't working terribly well. And the initial results for RoHS 3 are worse. We're seeing higher percentage of phthalates than people would be led to think. It's still extraordinarily common. You get a complicated piece of electronics. You get a couple of wire harnesses. The amount of phthalates in there is a lot. You have all these O-rings and gaskets and little rubber feet and dividers and strain relief. It adds up. The failure rate is quite high, especially if you do data gathering after the fact. It's not part of your specification. So we see failure all the time, even for the current RoHS, for lead, for hex chrome, cadmium, etc. Still super common. So data gathering after the fact is a very bad idea. This data gathering is basically I've designed and made a product and now I'm gathering data. Good question for you though. When you need a standoff, do you go buy a standoff and then measure to see if it's 10 centimeters? Or do you buy a 10 centimeter standoff and then potentially measure to ensure it's 10 centimeters? When you get a new enclosure, do you just design, you basically lay out an enclosure, buy it, have someone, and then look afterwards whether or not it's aluminum? Or do you specify in the enclosure's drawing that it has to be aluminum? And then potentially verify the first article when it arrives. That's the way you do things. So why are you treating RoHS any different? It's part of the design requirement, like the size, the color, the material. You want to say an enclosure it needs to be made of aluminum. Well, it needs to meet these requirements also. It's not something where you buy something and then figure out afterwards where it meets some compliance requirements. It's part of the design spec. It's part of it should be in the drawing. It should be part of what the supplier is committing to, not only what you're providing and building to, but what they're going to maintain. Again, when you buy a standoff, do you just buy a standoff and then measure to see what if it's your 10 centimeters? Or do you actually try to buy a 10 centimeter one and then potentially measure the first article to make sure it's 10 centimeters? When you get another enclosure, do you buy one and then check to see if it happens to be blue? Or do you specify it to a specific type of blue and then potentially do a color check to make sure it's the blue you want? That's the way you do things. And this isn't any different. It's just another quality materials requirement. So one of the more effective plans than data gathering after the fact is you create a restricted material specification that you can put on a drawing. So instead of saying must be compliant with RoHS, which is of course constantly changing and a pain in the butt right now, it must be compliant with Acme Spec 1, 2, 3, 4. And you control that spec separately. Not only can it be in drawings, but since you probably don't want to go back and open up every drawing of every part you've ever made, you want to be able to provide it separately to suppliers to get their commitment. You also want it to be separate so a designer can use it as a reference. One of the things we've noticed, and a great way to get buy-in from designers in this, is you add it to their design toll gate process, and they can't get out of a particular gate without certain compliance requirements. And what they really hate is they do all this design, prototyping, checking, and then right at production builds, you do data gathering or testing and find out it's not compliant and they have to go back to the start for things they never knew about. Many of them prefer not to get the part rejected later on and know what they need to be designing in. And the next thing also about a restricted material spec, separate one, is you can update it and revise it. Recast VHC changes every 6 months. A lot of these others are fairly dynamic. The persistent organic pollutant regulation is going through a rewrite right now. There's going to be a lot of change. Prop 65 changes quite dramatically. It's a really interesting chemical, 2-MBT, which is very common, coming into effect in November. Things keep changing. So you want to create a restricted material spec that you can put on drawings, can provide separately to suppliers, but also be able to acquire commitment from the suppliers that they're building, buying, designing, or providing that specification. This is what you need to build to. Single target. This is what we're looking at. And be able to acquire their commitment or their certification that they're doing that, and to encompass everything they're providing to instead of a part-by-part basis. Also much better on the ongoing. And then you want to test the representative products to ensure the process is working, like you do with anything else. You want to check, you don't check the full electrical functionality of every single product. You check something representative. And potentially in a family, you don't necessarily measure every part. You measure a first article. So what we know more is normally done in this case is the specifications created, the suppliers commit to it, and then you test to ensure they're meeting it. And the interesting part about this, even if you're wrong later and a supplier makes mistakes, which happen all the time, in inventory control, in materials, and understanding the regulations for that matter, and your product ends up having a non-compliance event, which happens a lot. As long as you have a test report, there's very little the national authorities can do to you. They will often negotiate, because this is, again, recycler safety, and you can justify the amount of lead or hexachrome you're putting on the market does not make a significant difference. And you've done the proper work. Here's the test report. They'll work out that you normally have some kind of compromise, such as you can't ship any new ones in until you fix the problem. And that's the common part. Even the best control processes, usually the supplier rate is error rate is about 0.5%. So if you have about 200 or more parts in your product, therefore more than half the time you're going to have a non-compliant product. It's just a mathematical issue. 99.5% quality rate is usually pretty good in most things. Unfortunately, it doesn't fly here. And so you're going to have non-compliances anyways. What you want to do is try to make it so it's part of the original process, that you can acquire data at the supplier level, which is a much smaller group than the part level. And if you keep using the same suppliers, it's a much better overall long-term process. And then you can test representative products to ensure it's working. And if it isn't, you make the adjustments. It's faster, easier, cheaper, and much better in the short and long term. We like in the short term because it's cheaper and faster. We like in the long term because it maintains compliance and makes it part of the regular stream. If you have a non-compliance event in the EU, which everybody will at some point in time, maintaining RoHS compliance, that number of parts is tough. The supplier error is too large. Procurement's usually trying to find a cheaper version of parts, and things happen. The national authority, and we've been through a lot of these, will ask for your test report. You might be able to get by with supplier data and explanation, but it'll be tough. And most importantly, you got to be able to provide them something. So if you're collecting supplier data, you better have something you can give them. We've had lots of experienced national authorities. They always ask for a test report if they found it themselves or been reported to them. And it's face value. If you don't have a test report or a tech file, they have you. And then the test result itself is anticlimactic. But if you've done the work, the penalties are much lower. And so you normally end up with a corrective action. It's kind of a big deal. And we're not doing compliance for fun. You're doing compliance because you want to sell in that space and you have deliverables. And one of the big things is when the non-compliances occur, which will be more common than most people probably here are comfortable with, you want to plan. So one of the ways we handle this, one of our most effective strategies is working with companies. We sit down with you and you work out your current compliance state. For EMC or restricted subs, what do you do today? Because usually when a new product's being designed, there is an initial stage where somebody says, hey, I'm going to sell in these countries. And therefore, at that point in time, they figure out what safety and EMC requirements they need to comply to. Well, why isn't the restricted materials there? Because it's another design thing. And so we look at what they do for the toll gate process or the gate process, especially for new designs to start with, and then map a future state on top of it. And once you figure out what you're going to do for new designs, we look at what you can do for change orders, because usually the tools or concepts you built for new designs or the buy-in you get there applies really easily to engineering change orders. And then we look at the tools created and figure out how to apply it to representative legacy products. One of the problems with legacy products is they don't necessarily have their own budget for redesign. So you have to often look at representative products and work on their compliance and look at expanding it to a larger family. And this is even easier for things that are declaration only, like Recast VHC. Then we normally create the standard compliance outputs to provide to customers. We don't want to fill in every customer's form, or which may or may not be corrected regulations anyways. We want standard compliance outputs that you can provide. Companies have gotten really familiar with the conflict minerals one, which is a standard, basically one-size-fits-all type response. You can do the same things for RoHS and REACH, etc. And we often, for a lot of companies, are on call in case they get unique or confusing requests. We can explain what it really means and what it is. One of the most challenging things, the company doesn't ask, their customer doesn't ask for, are you compliant to these regulations? They give this list of restricted substances alphabetically, which I'm not a chemist. Well, okay, I'm a chemist. It's still a hard read. I look at it and go, okay, and I recognize most of them, and I know how to work through it, and it's not very helpful. You really want to make the spec at a regulatory level. But we help a lot of companies with this. So remember, there's a better than average chance that even with your best efforts, your products will not be RoHS 2 or 3 compliant. The most effective plan for RoHS and any restricted substance in general is part of the design requirement. You make it part of the specification. And then you confirm acceptance of that spec at the supplier level instead of doing every little part. Probably realize the vast majority of your parts are actually from a small number of suppliers. And oftentimes people focus on the circuit board. Circuit board stuff is not very high risk of being non-compliant with the new RoHS requirements. And realistically, it's really part of their industry, and trying to worry about individual part collection at work with manufacturer is not a good plan. What you really want to do is, believe it or not, your board, the company that populates your board, they may say they can't get the data, but they generally only buy all their parts from 2 or 3 distributors, and most of them will have it on hand. You want to turn it over that way. Basically, make the compliance requirement at a board level, not at a part level, at an entire board. It's a lot easier and usually much more effective. And then you verify with testing representative products. You don't test everything unless you believe you have to, and everything keeps failing. And at this point, you got to test everything because you don't trust anybody, which, by the way, does happen at times. You test something representative, not only to confirm that the spec is being adhered to by your suppliers, but also it provides the easiest conformity assessment doc can provide authorities. So even if you're wrong, there isn't really any penalties. Summary of RoHS 2019, it's July 2018, except for medical monitoring control. It's the 4 low molecular weight orthophthalates, DHP, BBP, DBP, DIBP. Data gathering after the fact is not very effective. You designed and made the product, and now you're going to gather on a requirement that you didn't specify. And they basically say no, they can't sell to you anymore. Of course they're going to say yes. Or enough of them are going to say yes, when they wouldn't necessarily say they're intentionally misleading you, but maybe they haven't tried too hard themselves, and this allows you to keep selling to you. It's easier. Or you're talking to a salesperson, and he doesn't really understand, and he just sees RoHS compliant and tells you it's the same thing. Because then he could sell. It happens a lot. So for compliance plan, you want to create a restricted material specification. You want to ensure acceptance by suppliers, and then you want to test representative products to confirm compliance. It's a lot easier. Don't try to make this difficult for yourself. Do it properly and most effective manner. So again, you have any questions, please submit it. Unfortunately, I have a hard stop in a couple minutes. I'm going slightly long here. We do work in all of this space, whether it's the EU RoHS, the Prop 65, Recast VHC, whether it's helping you determine what you're supposed to be doing, or lab testing. We do a tremendous volume of materials through our product, our line. We have tremendous experience and know the best way to handle it. So if you have any questions, please feel free to submit in the chat box, and I'll try to get to as many as possible. If you don't have a question or want to follow up later, just contact me. I'd be happy to follow up. Oh, there's a good question. Where can we find more about the EU persistent organic pollutant? As the regulations be redesigned, it's going to be moved over to the European Chemical Agency, or ECHA. And at the point in time, everything's going to be much more organized. Until then, it's scattered hither and yon. Still better than the Canadian version, but the EU version scattered hither and yon. The main thing you have to know is the SCCPs are banned at 0.15%. And they're one of the most common sources of product recall in Europe. They're about 5 to 10 a week in the last little while. If you go to RAPEX and look up the recalls, just put in the free text section SCCP, and you'll get tons scattered all over the place, mostly flexible PVC. Quite a few countries enforcing, a little more than Nordic, Scandinavian countries, but definitely a lot of enforcement across the board. Very, very common. We test for EU persistent organic pollutants, super common. Also banned in Canada. Canada's enforcement's only just coming online. They're probably about 6 months away from enforcing heavily, but they'll probably be pretty draconian. There's definitely a lot of people they've caught. They just have some challenges with their test protocols to actually force the recall, but that should be happening in about 6 months. Well, not a lot of questions. Again, pleasure, everyone, and feel free to contact me with any questions. I apologize I have to drop off. I managed to double book myself in my infinite wisdom, but it's been great hosting everyone again. I apologize for speaking quickly. It's a lot of material to go through. There will be a recording, which you might not want to hear because it's me, but it'll be up on our website by next week, and everybody attending should receive a copy of the slides, I hope. Hopefully by tomorrow, but we have a lot of attendees, and it might take a little while to get it out to everybody. Pleasure again, and thanks for attending.